This is how to do a problem where you mix different volumes and concentrations of materials to find equilibrium concentrations. So we are given the reaction below, the equilibrium constant, and the information that we have 10 mils of 0.200 molar HCN and 25 mils of 0.080 molar lactate. Alright, well, this is going to actually start out as a dilution problem. So I'm going to keep my reaction table up here, but just down here, let me remind you that C1V1 is indeed equal to C2V2. So first I'll work on the HCN. The initial concentration is 0.200 molar. My initial volume is 10 mils. And I would like to know what is my final concentration when I take the 10 mils that's already in and add it to the 25 mils of other volume that I'm mixing it with. So I will solve for C2, and it turns out to be 0.0571 molar. Alright, well, I will write that down here under my initial 0.0571. I guess I'll grab an extra Sig Fig just in case things get wonky. There we go. And that's in units of molar. Okay, now let me work on the lactate. And initially I have concentration of 0.080 molar and 25 mils, and that has to equal C2, my new concentration, of the 25 mils that it came in with, plus the 10 mils that came in with the HCN. So I will solve for this C2. And it turns out to be exactly the same concentration as the other one. I'll add the 4 this time. That's actually by design. You're going to see that the math falls out easier that way. So I will put this as 0.05714 molar. And no product when I start. Okay. We will start the reaction, and it will shift to the right. So I will have minus x and minus x, plus x and plus x, because all my coefficients are 1. So at equilibrium, this will be my initial concentration minus some amount I lost. This will be my initial concentration minus some amount I lost, and x and x. Now I will write my equilibrium expression. That would be products over reactants raised to the coefficient. We've done enough of these that I hope you will just allow me to write x times x over 0.05714 minus x and 0.05714 minus x. Okay, which can be simplified as x squared over quantity 0.05714 minus x squared, and that has to be equal to my equilibrium constant of 6.3 times 10 to the minus 6. Okay, just like the last problem, it would be best if we took the square root of both sides. So I will be left with x over 0.05714 minus x, and I need to take the square root of my k. And that value turns out to be 0.002599. Alright, now it's time to group my x's and solve for them. I have X here, and I'm going to move this quantity over here. That will be equal to 0.0025099 times 0.05714 minus X, which when I multiply that in is 1.4342 times 10 to the minus 4 for this amount, and a negative 0.0025099x, and that is equal to X. So that means 1.00259 X is equal to 1.4342 times 10 to the minus 4. My X turns out to be 1.4305 times 10 to the minus 4 molar. And I'm actually being asked my cyanide concentration, which I represented as the variable X. So this would be my cyanide concentration. And I guess about the last thing I need to do is look at Sig Figs. My K was limited to 2 Sig Figs, so I guess I should say my cyanide concentration is equal to 1.4 times 10 to the minus 4 molar. Alright, that's how you mix and find concentrations.